This is what I'm fond of calling the Disney problem, because we get to make things work out perfectly. And the first thing we think about is standardizing this equation, because we don't, well, normalize. You know, we don't want to have this negative x squared. We want to have a nice positive x squared. So to do that, we'll factor out this negative and say x squared. See how positive it is? I know there's a negative sign waiting for it, but it's positive now. And since we did that to the x squared, we're going to do it to the 4x. The 4x is in on it. But I'm looking for something that will be perfect, and the 6 is not perfect. I want a perfect square, and the 6 is not going to get it for me. So I'm going to say, you know what, I'm going to add something here. And when I do, notice it's going to be negative. There's a negative sign waiting for it. So I may put a plus sign here, because inside the parentheses everything is perfect, but on the outside there's a negative waiting for it. So whatever I add here is going to have to be negative. But I haven't forgot about my 6. My 6 is unchanged. It's outside the parentheses. It doesn't have a negative waiting for it. It's positive. The only thing I need to do now is say, look at my middle term here. My middle term is 4. So I take my 4, and this is what I always do to the middle term. I divide it by 2, and I square the result. So 4 divided by 2 is 2. Squared, 2 squared is 4. So my perfect number is a 4. And remember that I said if I put in a positive 4, what looks like a positive 4, it's really a negative, because there's a negative sign out front. So I just added a negative 4. And I can't just add a negative 4 because I feel like it. So in order to make up for adding a negative 4, I'm going to have to add a positive 4. This one's really positive. There's no negative sign waiting on that 4. So I have to have the opposite amount on the outside here. Negative, I know it looks like a positive inside, but it's a negative 4 in there. So here's a positive 4 to balance it out. Now, why did I do that? Well, when you factor this, it becomes clear that y is equal to negative x. And you say, how will I factor this? Well, I know that I divided 4 by 2, so I'm pretty sure that it's x plus 2 times x plus 2. And if you FOIL that out, you'll see that that's what you get. X plus 4 is 10, so I have 10 waiting out here. And the perfect square comes in where I can say, you know what, I don't need to write it twice. I can just write it once and say that it's squared. Anything times itself is squared plus 10. Now, this is what we wanted, and the reason we wanted it, and what I'm going to show you here, is that we have a parent function that looks kind of like this. We have y equals x squared. And, you know, we can always graph using a tree here. We can say x and y. And when x is 0, y is 0. So guess what? We start down there at 0, 0. And then when x is 1, then y is 1 as well. So we go up here to 1. And the funny thing is, if we go negative 1 and we square that negative 1, we get a positive 1. So y goes up on the other side. It's a little bit like the one we just did with the absolute value. It's positive for the y, no matter what we put in for x, because we're squaring x. X is 2, we square it, and we get 4. So there we go. And you know that's going to happen over there on the negative side as well. And if I put in x is equal to 3, I square 3. 3 squared is 9. 3 times 3 is 9. So x equals 3, and y equals 9. So there's my parent function, and it's a parabola, and it looks about like that. I missed the dot, but it goes on, you know, it goes up very fast. And you say, well, okay, this kind of looks like that. We have y is equal to negative x plus 2 squared. I see that y equals x squared, and then I'm adding something. Okay, so the question is, we know we're going to shift this around, and we have x plus 2. So which way do you suppose that gets shifted? Well, you might think it's to the right, but inside the parentheses it's kind of backwards. So we're going to shift it 2 places to the left, and we're going to shift it 10 places up, because this doesn't lie to us. That's saying plus 10. It's going up. So this negative, or sorry, this 0, 0 dot, you know, that we started with, ours is going up to 10, and it's going over to 2. So there's our new dot. but it's not the bottom of the parabola like this one is. If you notice, look real closely, you see this negative sign out in front. That means that what our parent function is a happy smile catching rain. It's like that. Ours is going to be upside down because of this negative sign. Because of this negative sign out in front, because of that negative sign, we're upside down. The dot that was at the bottom of our parent function in blue here, this dot down here, that one, that's, oops, oh, that's not what he wanted. Can I undo that? Sure hope I can. Or at least blow it up. Let's see. No. I don't know. Let's try to undo that if we can. Possible? I don't know. We'll make the best of it, maybe? Oh, dear. Okay. Well, anyway, I'm going to go ahead and draw if I can. And I really hope I can. Doesn't seem like I'm going to be able to. Well, can I move this thing? This is unfortunate. If I could just crop it so it includes it, I'd be happy with that. I don't want to crop it, but I guess I'd take it. Whatever. Go ahead, let me draw. Okay, so we said that this thing was upside down. So if you remember, we said we go over one and up one. Well, this time we go over one and down one because we're going upside down. Over one, down one. And down here on the original parent function, we went over 2 and up 4. So now we're going to go over 2 and down 4 on both sides. Okay, so right there. And we go over 3 and down 9. So here we are. And we're upside down. So you don't have to be this careful, I guess, but you can sketch it upside down. We're going to try here. We're sketching it upside down. Very difficult to see. My line got really small because I cropped my picture, even though I didn't want to. There's my upside down parabola. It shifted 2 to the left. This used to be the bottom, but now it's the top. It got shifted over 2 places to the left, and it got raised up 10 places up. It used to be down at 0, now it's up at 10, and it's opening upside down because of the negative out in front. Alright, so it's the same parabola, it just got moved around and flipped upside down.